All right, let's just dive right in. AI, artificial intelligence, it's not some far-off sci-fi thing anymore. It is here, right now, and it's completely changing how we build software. But look, forget all the talk about robots taking over. The reality is actually way more interesting. The best way to think about AI isn't as a replacement for developers, but as this incredible new force multiplier. It's a tool that's here to augment our own judgment and our own creativity.
So this is the question, right? The one on everybody's mind. Are software engineers about to become obsolete? Well, the short answer is no. But the job is absolutely about to change and change dramatically. So in this explainer, we're going to cut through all the hype and really dig into what it means to be a software engineer in the age of AI. To really get a handle on AI's impact, you first have to understand that we're basically smashing together two completely different worlds. On one side, you have the structured, orderly universe of software engineering, and on the other, you have the experimental, data-driven world of machine learning. And the contrast here is pretty stark. Think about traditional software engineering. It's all about process, structure, and methodologies like Agile. The goal is to build something that is functionally correct. It does exactly what the blueprint says, every single time. It's deterministic. But machine learning? That's a whole different beast. It's way more experimental. It's about taking these massive piles of data, feeding them to a model, and training it to spot patterns and make predictions. One world is all about being perfectly right, the other is about being mostly right. And that leads us straight into this huge concept, the black box problem. See, with traditional code, you can read it, line by line, you can understand its logic, you know why it does what it does. With a lot of these ML models, though, the internal reasoning is a total mystery. There's a fantastic XKCD comic that just nails it, saying, sometimes it feels like you just stir the pile of linear algebra until the answers start looking right. And honestly, that lack of explainability is a massive culture shock for engineers who are used to building systems where every single step is auditable. Okay, so how does this new AI teammate actually plug into our daily workflow? Let's take a walk through the classic software development lifecycle, the good old SDLC, and see just how AI is augmenting every single phase. And to make this all super concrete, we're going to use a running example. Let's pretend we're building a simple college event management app. First up, figuring out what to build in the first place. You know how this usually goes, right? Endless meetings, taking notes, manually drafting these huge, long documents. Well, now AI can jump in. Imagine a chatbot that can actually interview stakeholders for you, asking smart questions to pull out the requirements. Or a language model that you can just feed a meeting transcript to and, poof, it generates the first draft of your technical specs. The whole point is getting a solid starting point and getting it fast. So for our college app, we could give an AI a simple prompt and get back a list that looks something like this. And, at first glance, it's not bad. It's got the basics. Users can browse events, register, organizers can create them. It covers the core functions you'd expect. It looks like a totally solid first draft. But this is exactly where the human engineer becomes absolutely crucial. Just take a second and look at that list. What's the massive, glaring hole? What's missing? Right? There's nothing about user accounts or logins, authentication. How do we know if a user is a student or an organizer? What about different permissions? The AI gave us a great skeleton, but it's the human engineer who has to add the muscle and the brain, because we understand the business context. All right, next up, architecture, the blueprint for our software. Instead of just locking yourselves in a room with a whiteboard for hours, an AI can now act as your personal design consultant. It can look at your requirements and recommend specific design patterns. It can automatically generate diagrams for you from a simple text description. And, this is really cool, it can even do a quick risk analysis, flagging potential problems before you've written a single line of code. For our event app, the AI might suggest a very standard client-server architecture with a monolithic server. Now, all monolithic means is that you have one big unified codebase on the server that handles everything: user registration, event management, notifications, the whole shebang. For simple application, this is a very common and sensible approach. But here we go again. The AI suggestion is just a starting point. We have to ask, what are the trade-offs? Sure, a monolith is simple to get started with, but what happens if our app gets super popular? Suddenly, that one big codebase can become a nightmare to scale and maintain. An experienced engineer knows this. They have to weigh this against other options, like a microservices architecture. So you see the pattern. The AI suggests, but the human decides based on long-term strategy. Okay, now we get to the part everyone's talking about, writing the actual code.
This is where tools like GitHub Copilot come in, and they're basically autocomplete on steroids. You could write a comment in plain English describing a function you need, and the AI pair programmer will suggest the entire block of code for you. It can also help automatically enforce a consistent coding style across a whole team.
So let's say we ask our AI to write a simple function in C to handle an event's name. It might generate something like this. It looks straightforward enough. It creates a small buffer in memory called event_name and uses the strcpy function to copy the input into it. Looks simple, looks effective, right? Whoa, not so fast. Any experienced C programmer is probably looking at this with alarm bells going off. That strcpy function, it's infamous. It doesn't check the length of the input. So if a malicious user provides an event name that's longer than 50 characters, it will cause a buffer overflow, a classic severe security vulnerability that could crash the program or even let an attacker run their own code. And this is the perfect illustration of the danger. Blindly accepting AI code without deep, fundamental knowledge is a recipe for disaster. So how do we catch dangerous bugs like that one? Through testing, of course. And guess what? AI is a total game changer here too. It can automate the really tedious work of writing unit tests, it can intelligently generate test cases for weird edge conditions you might not have thought of, and it can even use fuzzers to just throw all sorts of random, unusual inputs at your code to see if it breaks. For our event app, an AI can instantly generate a whole set of basic tests like these. It checks the happy path with a valid registration, but it also explores common failure points. What if the event name is empty? What if the user field is blank? What if someone tries a name that's way too long? This automation provides a fantastic safety net for all the most obvious cases. But you know the drill by now. We have to ask, what's missing? What happens if two people try to register for the last available spot in an event at the exact same time? That's a complex concurrency issue. What about testing the entire user journey from start to finish? The AI is great at generating these small, focused tests, but those complex, business-critical scenarios still require human ingenuity to design and validate. We've seen how AI can speed up development, but it is not a silver bullet. So now it's time for a reality check. We need to talk about the significant, hidden risks that come with integrating these powerful tools into our workflow. Just take a look at this number, 40%. According to one study, a staggering 40% of programs generated by a popular AI assistant were found to have exploitable security bugs or major design flaws. Let that sink in for a second. 40%. That is a massive number that should make any developer pause and think very, very carefully. So why is this happening? Well, there are a few key reasons. First, these models learn from huge amounts of public code on the internet. And unfortunately, a lot of that code is full of bad habits and vulnerabilities. Garbage in, garbage out. Second, the AI has no specific context. It doesn't know your company's security policies or the different roles your users have. This leads it to make common mistakes, especially around validating user input, which opens the door to classic attacks like cross-site scripting or SQL injection. So, given this incredible potential on one hand and these very real risks on the other, what's the new mandate for the software engineer? Well, the role isn't disappearing. It's evolving. It's becoming less about typing out boilerplate code and much more about strategic oversight, critical thinking, and risk management. This means we need a framework for deciding when and how to use AI responsibly. Here's a simple 4-point checklist. First, is there a better, simpler tool for the job, like a type checker? Use that first. Second, what are the odds the AI will even get this task right? Third, what's your risk tolerance? The cost of a mistake when an AI is answering a medical question is way higher than when it's just generating a unit test. And finally, and maybe most importantly, do you have a way to check the output and minimize the cost of an error? Okay, let's bring it all together. The bottom line is this. The software development lifecycle still runs the show. AI is just automating some of the smaller tasks within it. Human oversight and accountability are absolutely 100% non-negotiable. And yes, you'll need new skills in prompting AI, but your core engineering principles are more important now than ever before. So think of AI as your most powerful new teammate, one that's brilliant, but still needs your expert guidance. So in the end, this isn't a story about being replaced. It's a story about being augmented. AI is handing you the most powerful set of tools ever created. The question isn't whether it will take your job. The real question is, are you ready to step up, guide this new teammate, and lead the future of software development?